Okay, so this has to do with testing the drilling speed of hand drills, the holders actually. So I've got 3 different types of holders here. I did an earlier test where I compared the Petzl Rockpeck to a tapered holder. So this is, I made just a mock-up real quick of a taper holder, and how this works is I took a standard SDS drill bit like this. I cut it down so I had a tapered connector. This just fits into here, which has a tapered slot, and you can take it out with a wedge out of a bolt. My idea here was that the impulse of the hammer strike would be transmitted more directly into the drill bit by the solid connection than by the looser connection of the Rockpeck. Turned out this was much slower. This was about 2/3 as efficient at drilling as the Rockpeck was. I think one of the main things is that this large hole creates a disruption in the path for the impulse. So if you strike the head of this with a hammer, there's a little compression wave that travels down through the holder and into the bit and eventually into the tip. And the efficiency has a lot to do with how directly that impulse travels from here to here. And I think this hole interrupts that path. So this turns out not to be a super efficient way to drill, apparently. So we're going to do another test today, comparing again the Petzl Rockpeck with one of the holders that I make. This holder is a little bit different than most because it has a particularly deep socket. Come out of there. So the drill bit sits pretty deeply into this, so the distance between the striking surface and the end of the drill bit is only about 1 inch. So the idea here is that the impulse is going to be transmitted pretty effectively to the drill bit because all it has to do is travel through 1 inch of basically directly connected steel. So how this works is there's some little set screws here on the side. We insert the bit with this rounded slot lined up with the 2 set screws, and we set those deep enough. They don't have to be tight, but just deep enough so that the bit doesn't fall out. So for example, if I line this up correctly, these just turn a little bit. Of course, it helps if you have the right size Allen key. I apparently don't have the right size Allen key. Anyway, these sit in here, and even I did that wrong, huh? I think I didn't have the bit all the way in. There we go. Okay, so these don't have to be tight. They just have to be into that slot so the bit doesn't fall out. There. So that's what we're going to test. To do our test, first what we're going to do is take a couple of brand new drill bits. So These are some Makita bits that I typically use. Part number is D, as in dog, dash 00928. So we're going to use 2 brand new bits so that our data isn't thrown off by, dissimilar drill bits. Sometimes I sharpen drill bits, and of course they wear out and get duller. So we're going to take all these old drill bits, get them out of our way, and we're going to stick to 2 brand new drill bits. These are kind of my go-to drill bit brand. You can usually, if you get these in a box of 25, you can usually get them for about $2 a piece. So we have 2 nice brand new drill bits. And put them in our holders. So the idea here is that the simple drill bit holder here should be more efficient than the rock peck. The rock peck's basically solid from the impact, but there's more material between the hammer strike, and the end of the drill bit. And plus there's more moving parts and things that absorb energy, so that's what we're going to check. We're going to see. Okay, so procedure here is we're going to drill 2 holes, one right here and one right here, using the 2 drill holders. And we're going to hit each drill holder 20 times. Then we're going to switch between drill holders. And after we probably go about 60 hits, like 3 cycles through that, we'll start measuring the depth of the holes with a dial indicator. So we can use the depth probe here to check it. So I'm going to start off here with 20 hits with the Petzl. Okay, so that's 20 hits. The first hits don't really count so much because sometimes you bounce out of the hole. So the first couple of cycles probably aren't going to be very effective, but we'll just keep going until I have a hole at least 2 inches deep. That's 20. We'll switch back over. That was 2 cycles of 10. Kind of lost count. Counting to more than 10 could be an issue. Anyway, so I'm going to clean these holes up. This cycle was basically just to get some holes started. Probably not much comparison at this point. And then we'll switch and start drilling more consistently. Two. 0.22. 0.322. That's my drill holder, and then for the Petzl, what we have is 0.322. So that's pretty amazing. We're exactly the same depth at this point. So I'm going to try to be consistent here and always start with the Petzl. .603. That's for the Petzl. And for my holder here, we have .590. 0.590. So the Petzl's a little bit ahead at this point, but they're pretty close. Anyway, I'm going to keep going. I'll be back. Okay, we're a few cycles into this. I'll film another one. We're about just over an inch down. This is the Petzl, it's 1.257. And this is the drill holder I make. This is 1.455, so we're gaining a little bit with my drill holder. I can kind of feel it because it feels like the hits are more solid, less spongy. Okay, I'm going to keep going. I'll be back. Okay, so this is the rock peck. That's 2.003 inches. And this is the bomb proof. 2.444 inches. I think the bomb proof is going faster, which complies with my theories about how these things work. So here's the numbers. Some of these were 60 hits, a few of these were 80 hits, and I think maybe one of these first ones I did some other sequence, but basically the number of hits is the same. So you can see they started off exactly the same. The Petzl was a little bit ahead on the second series, but after that the bomb-proof drill holder was clearly ahead all the way. I'll crunch some numbers and see how that looks, get some percentages. Okay, I've looked at the data we collected. Here's the depths of the holes for each cycle for the two drill holders. This is the change, so this is from 0.603 to 0.801. The difference between those is 198. So this is the change for each increment. I think I got my count wrong a couple of times. I think sometimes I got 40 hits instead of 60, things like that. Anyway, so I think the number of hits for each drill holder for each cycle was the same. So what I've done is compare the incremental differences. So on the first cycle we had exactly the same result. The second cycle, the Petzl was a little faster, so I got a ratio of less than 1. For all the other cycles, the ratio was greater than 1, except the last cycle. Not sure what happened there, but that one was high, was low, I mean, as was this third cycle. No, the fourth cycle, 1.13. So it looks like most of the cycles were doing pretty well. We got a couple of low ones, but the average of all those is 1.25. So I think based on this, it's fair to say that the bomb-proof drill holder is about 25% faster or more efficient. Okay, thanks.